Titanium foam. Titanium foam can be defined as a metal foam that can be used in many ways. These ways will be discussed later in the slides. Some related materials would include the following. Titanium. Due to titanium foam being made up of 99.8% of high purity titanium powder. Another includes aluminum foam. It has the same idea as the titanium foam, except it's made with aluminum. And lastly, titanium alloy, which is a mixture of titanium and other chemicals. Titanium foam has a light gray color, and it looks like other foams that you could find at the store. These are pictures of titanium alpha and beta. I was unable to find the crystal structure of titanium foam. However, because titanium foam is 99.8% titanium powder, I assumed that this would be the closest thing to titanium foam. The mechanical properties of titanium foam include the stress-strain curve. Around the slide, you will find the different stress-strain curves that occur for titanium foam. Continuing on with mechanical properties, other basic information can be seen to the right. For example, the shear modulus is 116 GPa. The yield strength is 60 MPa. The tensile strength is 104 MPa. The design and safety factors include transport information, and the price can range from $35 to $50 per kilogram. The density of titanium foam is 4.54 grams per centimeter cubed. And some main mechanical engineering applications include water fuel cell, ceramic fuel cells, and hydrogen gas generator. Others can be seen on the slide. The thermal properties of titanium foam include thermal conductivity, which is 21.9 at 298.2 Kelvin. It has a thermal expansion of 8.6 at 25 degrees Celsius and has a melting point of 1,668 degrees Celsius. The production of titanium foam starts when the titanium is mined through a process called strip mining. In a simple term, they blow up the ground with explosives till the soil is torn up, and the company then sends the rocks to a dumping site, and the soil with the titanium in it goes to the factories. When it arrives at the factories, they mix the titanium powder with polyurethane foam and a variety of binding agents. The foam is then saturated with this mixture. When this happens, the powder attaches itself to the polyurethane matrix, and then it is vaporized away. The final step is to heat treat the foam to harden the latex. Now you have titanium foam. I was unable to find the history of titanium foam. I figured I would tell a little history about titanium, however. Titanium was discovered by William Gregor in 1791 and first isolated by Johannes Jacob Berzelius in 1825. Its name comes from the Greek god Titan, the god of enormous strength. Related industries include pharmaceuticals, water treatment, food, bioengineering, chemical, and petrochemical. When recycling titanium foam, there are two different ways you can go about this. The first is vacuum arc reduction. This uses scrap, sponge, bulk, or a prior VAR melt. The DC powder is used to strike an arc between an electrode and a base plate of mold, which is contained in a water jacket. The heat created by the electric arc melts the tip of the electrode and the new ingot gathers the mold. The second way is known as the cold hearth melting. This melts the material twice. The first time, the companies used numerous EB guns to melt the raw material using a cold hearth. The cold hearth purifies the metal, and then step 2 begins. They remelt the EB electrode in a vacuum arc reduction furnace. The electrode becomes further refined using an electrode arc. Through the usage of controlled and constant melt, the arc melts one end of the vertical electrode into a crucible. It then cools and hardens. Titanium foam's footprint includes CO2 and H2O. Because of the heating process, it creates the CO2. And even though titanium foam dissolves in soil, it can be very toxic for small water organisms. Applications include the military combat vest. The combat vest with the titanium foam in it has apparently been able to stop a bullet better than the vest that the Army has been using. Biomedical engineering. There have been an undergoing study in using titanium foam as a replacement for bones. The bones start to go around the titanium foam, and the results are showing great figures. If truly successful, it will make great strides in not only the medical field, but also in dentistry. And lastly, aerospace. Mechanical engineers have created a way to place the titanium foam in a sandwich-like way in between the structure panels. For example, in the bodies and floors of the aircraft. Finally, when researching titanium foam, I came across a study that tested the failures of titanium foam. Some of these findings can be seen to the right, which include titanium foam that has a 60% porosity has a higher Paris exponent than the solid titanium. The high Paris exponents are likely due to the crack closure and crack bridging. The solid coating on titanium foam leads to the lower crack growth than with the uncoated foam. And lastly, the medical applications are not restricted by the crack growth rate. I hope you enjoyed the video and thank you for watching.